and here with Michael, and look at this stunning urban Hackerspace streetwear. Doesn't he look stunning?
Very cool, very cool.
He's going to tell us all about his new do-it-yourself
3D printer.
Tell us.
Okay, so basically I've got a printer before, but I wanted to make something new, so I wanted to make it as something that was fairly readily available as far as the framework goes. So I purchased this aluminium box tubing, 25 by 25 millimeter tubing, and plastic joiner connectors from Bunnings. And basically, if I had have made this out of T-slot, it would have cost me around $400
just for the frame.
Just for the yeah. By the time I do the nuts and the joiners and stuff like that. Whereas I've done the framing on this for about $160.
Nice.
So, and as you can see, it's quite it's quite
sturdy.
robust.
Yeah. What's the total length of that?
This is 700 by 130. And I built this one from a few different designs, based on a few different designs, but it's taken on many different, like there's a nice big scrap bin of yellow parts at home that didn't make the actual build. But luckily with the Hackerspace, I've had a lot of different people that were able to share the load and make different things for me. So, but the basis is that we have two extruders. So they're dual extruders rather than be joined together like they would normally be at the current. Someone's actually done the hard yards with the Marlin firmware to actually make the independent extruders work independently. So when it's actually running, this one of them will sit in its home position while the other one does its thing. It could be either two different colours, or one could be a support material, stuff like that. And this one will then return to its home position, and this one then will come in with its other colour. And what it can actually do is you can set, in the firmware you set an offset so that it knows how far to travel before it actually collides at the collision point. And what it can do is you can load the same model and tell it to duplicate, and it will act happily. Then both these extruders will travel at the same time, producing the same part, because the y-axis will still going to travel the same way. Doesn't matter which way these extruders are happening. So all the parts are custom built from scratch. I did steal the parts from somebody else originally, but unfortunately the track that the printer's gone down, I haven't been able to use them anymore, and I had to go down the route of creating them all myself. So, everything's custom built.
And how big's your build?
Yes. Now this is the trick. This is my build platform. So we've got
that is enormous.
420 by 210. So for those people who know Prusas and General 3D printers, it's basically two of your standard PCB heat beds side by side. So I currently have a Prusa Mendel that I extended to run two different beds, but the problem was that to get the height of what I lost travel height, and the momentum because the bed on my current Prusa travels this way, so it's quite a bit of work on the motors when this starts to get going. So obviously I had to jeopardize speed for the factor that it was just going to.
Right, so by mounting in that orientation,
so now we're going to go in this orientation. Yes, much less travel.
To travel faster.
I should get a travel fast travel rate, because it's not now. I mean, it's a little bit different now too, though, that with the new firmwares and the ability to have jerk settings, so it doesn't or deacceleration. So the bed can travel in one direction, then before it reaches its end point, it can slowly deaccelerate. But the advantage of this is that I have two Prusa size beds, so anything that most people can print, I can, with this new dual extruder setup, I can print two of at one time. So the objective is that if I'm going to build the average 3D printer Prusa, I can basically print the whole kit in one print. So,
and you've oriented your shafts like this. This is your drive shaft down here.
Yeah, there's a lot of the current printers now are moving away from the motors being mounted to the top,
right?
Because obviously it obviously puts a lot of weight when the motors are being pulled this way.
Got it.
So the whole idea of what we got here is that this part here is designed to take the weight, so that the weight isn't on the actual motor itself. A lot of designs where there's this shaft's either hanging directly from the motor, or it's pushing down directly on the motor, and it's actually forcing, because there's a spring-loaded coupling here. So the weight actually affects. So whereas this system now allows me to keep the weight up off the motor shaft and purely allow the motor to actually do what it's supposed to do and turn the threads. But you know, after having a 3D printer before, realising that even the best printers, you know, you like to get in here and do this little tweaking action. So rather than do that, I added, you know, little
you can just rotate that around and tweak it.
Yeah, just tweak it around. So
nice.
But because it, because I had dual extruders, I had to change the design, because I had to. Not most 3D printers have only got one motor and what do you call a pulley on the other end, right? But because had to have dual, I had to have two, so I had to create a system that allowed me to have two motors and two pulleys at either end, so they wouldn't collide. But what I would say though is that a lot of I don't like the printed bearings.
Right.
As the printed bearings don't work very well. So I went down the road of speaking to Mr. China and making sure get Mr. China to look after me, and I bought proper bearings. Plus, what it allowed me to do is that originally I was going to have much longer dual bearings here, and have a much wider plate that the extruder was going to fit on. But because because these are 12mm rods, these are really strong. What it allowed me to do is that these bearings just happen to be wide enough that there's no play in there. So now I've got such a really narrow mounting for the extruder. It makes it really cool, because otherwise it's designed when I get to here and I come to here, so it's designed so that this
it can
still
go right to the edge.
Go right to the edge.
If I had the whole build area.
And the same with this end, it goes got to get right to the build area. So if I had much bigger than that, I mean, I'm really already wide as it is to then have to take it any wider. So it's it's probably not a model for the faint-hearted, but because the thing is that in the build process, because I haven't got slots in my rod, when I had to be very accurate. So when I screw these in, if they're not straight, well, then I can't move them half a millimetre higher, because now I've got we all know what happens when you drill a hole and you can't move it half a millimetre. So therefore, I'd have to all go down the route of putting bolts in, and if I had to put a bolt in one, I have to make the whole printer uniform, because it has to look nice, and I'd have to change the whole design. So
terrific.
There it is.
And it's designed to go in a suitcase.
It's designed in a suitcase. Yes, sorry. So the steel platform would come off, and this then will lock into here. And I'll have a carry strap
over the top, and
then I'll be able to just carry it around and make it transport. So that this will go this way. And everything will fit.
Nice.
I need to lock it up. So
and the print head. Have a look here. You've designed. You're using an extruder designed here, is it?
Yeah. Well, this is our own design. Basically, what this is just a aluminium plate. Because what it does is it works as a heat sink. So, and then what we're doing here is we've seen someone create an idea with this, where I think it's Joseph Cruiser created an idea where the actual heat block clamps on, and then we now use heated cartridges rather than resistors like they're using now. So what we thought, well, if we're locking this on here, then why don't we lock it in here. So this pushes up in here, and we lock it in here, and that's fine. And what it allows us to do is, because of so many materials now, that you can't use the same. It's not really good to use the same nozzle for multiple different materials. So what we wanted is a way to quick release, unlock this, take the outline out, put this on in, lock it in, and away we go again for a different material. So I try, having a 3D printer for quite some time, and being at Hackerspace allows you to mix with different people to then obviously come up with things that are unique and in the best fashion. So. And
you've designed all of these bits and 3D printed them from scratch.
Well, the only thing that's not original to me is this extruder design.
Okay.
But other than this extruder design was supposed to bolt on the bottom of a plate, a moving plate. I've made it mount 90 degrees and add this big block of spacer, but then outside of that, everything is totally from scratch.
Right. How many 3D printed pieces all up?
Well, there's a lot. there's a lot because this is the rod clamp here.
Yep.
This is a flat piece here.
Yep.
And then this other part here is another piece that bolts together.
Right.
So
that's a lot of work.
Yeah, it was. I mean, as I said, there's quite a substantial amount of yellow plastic in a box I've got at home through some trial and error and thinking that there was something there that was going to work for sure, and you bolt it on, and it's like anything, like electronics. You can design the best, and then it's not until you put it together that you realise that something doesn't work. So. And
how are you going to clamp this onto the base?
Okay, so what's going to happen now is I want it to be able to make it level, so I printed these feet. So basically it takes a 5mm 5mm bolt, nylon nut, and then unfortunately I have to pull this frame off because I've got square blocks made for here that have got countersunk nuts in them, and I'll drill holes and then make the feet adjustable so I can crank it up. And once I've got it up off the table, then I can put mount 5mm bolts through the base that then this will then centre and lock onto, and then have a couple of spring washers and wing nuts to lock it down. So, and as you were saying before, that my only fear, and I'm not going to know till I get going, is with the momentum how much with the narrow base.
Yeah, it's narrow here. So
there's other printers out there that use this narrow style base. Is how I got the idea. So I've gone. There's people printing successfully like that, but not at such a great scale. So therefore their momentum and all that's not anywhere near as much as mine. So it's just going to be
suck it and see.
Suck it and see. Yeah, I wasn't going.
Well, you can always add, extension feet out here like this.
Well, I've got plans, because obviously the joy of these joiners is obviously I've got a 3-way connector in here now. I can simply go back to Bunnings, get a 4-way connector, and just add another rod for feet. So
too easy.
This was the best. This is the best idea I ever done was go this route, because originally it was 100mm narrower because I wasn't going to have dual heads, so the distance was fine, but because I had to make it bigger, I just cut a few extra long rods and fit it in, and Bob's your uncle. But there's been many iterations of this design where originally, for some strange reason, I had these ones that come up here and they went back, and I thought, oh, that's great, what I'll do is I'll mount my electronics in there,
Right.
And then I've gone, holy crap, the plastic's going to travel in here. It's another one of those things where you have a brain freeze until it's all together. You go, oh, holy crap, it's not going to work. But yeah, I have to say, if anyone was going to have a look at building a printer, seriously, go down to Bunnings and just buy a few bits of this. It's cheap. It's cheap, really. Go and buy one link and get them in a 1.5 2 meter length, I think. Go and buy yourself one length of that and half a dozen connectors, and like Lego, just cut some up into lengths and just whack this together and go, oh cool, see what I can make, because it's really, really good, and it's much cheaper. As I said, it's much cheaper than T-slot.
Yeah, they're very expensive.
And if you go, oh, I make a mistake, you go down to Bunnings to get some more. If you cut something too short out of something that's come from the US, or when you get it from here, it's $50. It's a really expensive $100 cut that you make, and it's gone. So,
well, it's looking good at this stage.
Yeah, no,
looking really fantastic.
Good. Really good.
And another couple of weeks left of work, maybe.
Yes. So basically, all I've got now is other than the feet adjustment, which is not a really huge process, is the electronics. So once the electronics are done, because I'm going to run 24 volts, the whole system on 20 volts, because sort of the electronics allowing you to go that way now. Because rather than power these motors with 12 volts, this is a very big machine. This is a pretty big machine. So obviously I'm much better than running on 24 volts, because I'm going to get a lot more grunt out of it. So and my because I'm running 2 Prusa heat beds, I have to run them. I wire them in series, and I run them on a 29 volt power supply that obviously I tweak up to 24 volt power supply that I tweak up to 29. Just because otherwise it takes a half an hour for the temperature to get up. So I need to just spike it a little bit and get the temperature up. But the other thing that I had a look at is that I want to get the heat up really quickly. The problem is the next thing is now, because I'm using Kapton tape and stuff like that, is the factor of getting the temperature down without having to wait.
Got it.
So I decided to mount 2 50mm fans in here. This is where
you can blow it, right?
So then when it finished, add some command the G code, and then cool the bed down to get
very
it fast.
nice. Any concerns about warping on such a huge build plate?
Yes.
Yeah, we'll wait and see.
Yeah. But now, I mean, obviously, my personal opinion is that if you're going to build something big, you need to use a brim. So most of your cucuras or your slices allow you to have brim around the outside. I find that what you build underneath it.
Oh, raft.
The raft's crap. Raft's crap. You've got to spend 2 years to getting the raft off, as compared to because generally you don't have a problem with the middle of your part lifting. It's always the edges. So either turn brim on, or if you don't want to turn brim on, just be very smart on adding a little circle or anything to the corner of your model, if you can, and then to trim it off later, and that'll solve your problem.
Nice.
So, but yeah, it's been an exercise, and look, I touch wood. Touch wood. When we get to the day we turn it on and crank her up, that she runs smoother than what.
And you'll post some videos?
I will post some videos.
Fantastic.
So can we get a quick plug in?
Yep.
Also I run a 3D printer parts website called 3dprinterbits.com.au, where you can get all your motors and plastic and belts and all things 3D printer. It's Melbourne based. So we'll send all around Australia and stuff like that. So yeah, 3dprinterbits.com.au.
Awesome. Thank you very much, Michael.
No worries. Thanks.